So welcome everybody to this research seminar. I'm sorry we are a bit delayed, that happens sometimes. I'm very happy to have Fredrik Charpentier-Ljungqvist here, who's going to speak about impact of past climate variability, lessons for the 21st century. Fredrik is a professor of history, especially historical geography at Stockholm University. In addition, he is a Pro Futura Scientiam Fellow at the Swedish Collegium of Advanced Study, I think. And he received his PhD in 2014 at Stockholm University, a dissertation on kingship and law, a comparison between Denmark, Norway and Sweden in the High Middle Ages. But Fredrik is mostly well known for his in this kind of new wave of climate history. Of course, climate history has been around for a while. I guess most of us know about the volcanic eruptions in Iceland in 536 and the kind of winter that followed after that affected a lot. But Fredrik part of this new way of really studying this, how it affects human societies, and has written extensively both in scientific articles and also in more popular books on this. For example, I can very well recommend Climatic och människan under 12 000 år, a book in 2017 that Fredrik wrote, but also a number of articles in English for those who are interested. So Fredrik, you're very welcome. The floor is yours.
Thank you so much, and thank you for the kind introduction and for the invitation. I will only now today touch a little bit about this topic, and especially two research projects, one that will end this year and a new one that will start during the summer, with a brief introduction to these overall topics and what outstanding challenges there is with this project, and the state of current research and research gaps related to this project. So I will give also a brief introduction, because this is a huge topic, as already said in the introduction, and it's also a topic that is highly interdisciplinary. And I might myself have an advantage in that, because I'm also unsalaried associate professor of physical geography, that is docent in Swedish, and have worked extensively with natural science proxies, especially tree ring records. But to build up a research group in a Swedish environment is highly challenging in this type of topic, due to different disciplinary traditions, but also of various institutional reasons that it's, for example, few people that are heavily involved in very good computer programming and statistics and GIS are very interesting to be employed at a history department for various reasons, including the salary level. But that's that I have solved by good international collaborations, and also having my postdoc abroad employed in Germany on my grant. So you can go around all these practical problems. And in the beginning, when I started to pursue this field, I said, in Scandinavia we don't have this type of research. You can do it in the Czech Republic, in Switzerland, you can do it in Germany, but no, not here. And I said, yes, you can do it here, and I think I have actually established this a bit with both on the now local level, with actually people, postdocs from next year, 24, that will come to my department of history. We don't know the background yet, by Wallenberg funding, and also by having this huge different layers of collaborators in various ways at numbers European universities, because compared to traditional, maybe historical research, it's more similar to laboratory archaeology, archaeological science, that this is a teamwork with different expertise, and you also publish always in teams. But that said about the challenges and the prospects. So we know a lot about, of course, climate, since the challenge of anthropogenic climate change have increased the research about past climate, also to partly to contextualize recent changes, but also to better understand the climate system. And this research are really taking a new turn, and most scientific findings have been done in the past 15 to 20 years. I would say the past 10 years in Europe when it comes, if you look at European perspective and look about past droughts. So it's very recent, the scientific basis, and also ways how to connect it with, for example, human health in the past. So one bottleneck here is that climate, it's the average of the weather over a longer time span, typically 30 years, that's the average. But it's not only the mean state of temperature, precipitation, circulation patterns, air pressure, etc. It's also the distribution of extremes or anomalies within this 30-year period. You, for example, can have a few very cold winters or very dry summers in a certain place. And how the distribution of this average over 30 years is. And that's very important, because when the mean state changes, the distribution of extremes also changes. Typically when it comes to temperature, it's just a shift towards more, in a warmer climate, more warm extremes and fewer cold extremes, and vice versa. When it gets colder, you get more cold extremes and less warm extremes typically. But you also have the matter of precipitation and various drought metrics. And I don't want to go into that because you can measure droughts in very many ways. But precipitation is very local scale, and both its seasonality and its amount might change in different directions or not at all with different temperatures. And since temperature work on a larger scale, precipitation on local scale, it's very challenging even with contemporary measurements and in the contemporary understanding, and it's even more or almost a huge challenge when you go back in time prior to meteorological measurements and need indirect data like drought sensitive tree ring records and so forth. And we can also in general say, and this is a scientifically hot topic, maybe be, I don't know if the best word here in this topic of climate change, but it's a hot topic. How much have climate changed various parameters over various time scales and at various places in the past? It has a huge implications for understanding of the climate system and the contribution of different forcings. And this is a highly politicized topic, and I could give own lectures only in that topic, especially since I've been expert reviewer in IPCC 3 times. And this is a topic that is where science and politics meets, and it has various implications I can't go into today. But it has one implication in the study history, archaeology. If you have larger change in climate in the past, at least on regional scales, then it implies that climatic changes have had a larger role, so to say, an agency in past human societies in history. Then if you have had only smaller changes, you can suppose that they mattered less. So this, if you studied both multi-millennial perspectives in archaeology, but also in the discipline of history, economic history for, say, 1 millennia, it has implications, for example, for food production and vectors for diseases. How big has the changes been? But leaving that aside for a moment, I will show how you can think about climatic change. We have climatic change as a forcing. We have the change of the mean state, but also the extremes, and that can affect the frequency and severity of different weather patterns that might be adverse or beneficial for human societies. All depends, of course, on the time and the place. And we have the first order impacts of climate, and typically you're thinking most of the first order impacts, and that's basically the quantity and quality of primary production, biomass production, and also of like water energy and the built environment, but also of course crops and domestic animals. It's food production. That's the first and foremost impact on food production. Is it increasing the fruit production, decreasing it, or increasing the variability in different in the yield of different crops, or is it stabilizing the crop production. And then after that, in the past societies, as to a certain extent today, you have secondary impacts. You have, for example, if the crop yield decreases, you will probably have an increase in price of main food staples, and that can have secondary economic implications, especially in pre-modern economy, where 2/3 or so of the income of day laborers went to food. If you have a huge increase in food prices, that will cause hardships, but it will also affect the entire economy and put it in kind of depression, because you will not be able to afford any other products than life-sustaining food, and that will lessen the demand on other products, and can have huge economic influences. And we can see it, and still in the early 18th century in Europe, until the 1770s is the last time we see such a shock in Central Europe, where you actually have no demand for like clothes, hats, shoes or so among the poorest strata of the population for 2 years, and the protein industries are basically put out of business due to 3 years of poor harvest, that you can't afford other products. So this has implications for the economy also, and for the society at large, not only the demographic fluctuations in a Maltesian society. And finally, we have the third order impacts of this. The demographic impacts are the clearest, and we have also, of course, migration and human well-being and social conflicts and so forth. And all this is much harder to actually directly link to the climatic forcing, because you have these different first order impacts, second order impacts in between. So you have so much human agency that between the direct climate impact and the social outcome. So it's almost impossible with normal reasoning about causality to directly link with certainty the social outcome to climatic events. And this also means that you need an interdisciplinary perspective, because you have, of course, this first order direct impacts of climate, and it filters through society. And depending on how the society is structured and what means of production you have and what technology level you are on, this could, depending on time and place, also have different outcomes. And a certain outcome is typically not given. It depends on the society. And here, human agency and climatic forcing, we can call it climatic agency, will interact. And you also have, to complicate it a bit, the fourth order impact, because humans respond, or are cultural beings, and also respond in different cultural way. With cultural responses in the past, it could be religious responses, but we also have the scientific, artistic, different societal reactions, and also the culture memory and the learning and adaptation process, because you adapt and adjust to changes in the environment. Or if you don't do it, it's interesting in yourself why certain societies don't adapt. So what is then the state of the art knowledge? And I will only go, due to time limitations, about the first three order of impacts. The first order impact, and I will focus, this comes from a quite recent review paper I published 2021 with two of my collaborators, about what you find for medieval and early modern Europe. It's basically from 700 AD until 1800 or so, and for Europe, what is the main state of current research. And we went through enormous amounts of research to try to pinpoint where the state of current research is in this topic. And we can see very clearly that climate has governed the potential, the limits, and the risks associated with grain agriculture and pastoralism in Europe. And we can also see very clearly that in general, cold climate, especially cold springs, have generally resulted in adverse growth conditions, whereas warmer climate states in the past millennium, especially warmer springs have resulted in more, so say, favorable conditions for food productions, at least in all of Europe north of the Mediterranean. And almost all large-scale harvest failures were caused by cold and or excessively wet conditions, and this is especially true for the consecutive run of poor harvests. And the reason for this is mainly that climate has less memory when it comes to precipitation. We have both the spatial scale, precipitation patterns are relatively local, and severe summer droughts are typically not consecutive. They can be consecutive for a few years, but it's rarely to have a long run of them. But you can have a long run of cold and, for example, cold springs or cold after each other, and this can also be related to the forcing. For example, you mentioned volcanic forcing, and with volcanic forcing of this level we have not had of this magnitude since the early 19th century, but it was common during the so-called Little Ice Age in the early modern period and late medieval time that you had volcanic forcing that forced cold conditions for several years after each other. And if you look at drought, we have had droughts similar to 2018 that could devastate and especially spring crops, but it occurred here 1 year, and the years before and after was fairly good harvests, and that's typically also in the past. So cold conditions were typically worse, and in Central Northern Europe it also meant less spring pastures, a delay of the onset of green grass. So the domestic animals might got their calves and born their newborns when it was still no grass, and we had very little fodder in pre-modern agriculture. You didn't cultivate fodder. You could have hay, but there was typically no hay left in the late winter and early spring, and then you would have an increase in animal mortality, and that also in a pre-modern society would mean less manure to the grain fields for several years to come if the domestic herds were decreased. And I mentioned this with droughts and excessive precipitation that typically have severe impacts on the local scale and also our transport infrastructure. Both frozen rivers could be bad in winter in Central Europe, where you were used to have transport year-round. Up here it could actually be good in inland areas due to slate transport, but in most of Europe that was bad. But also very dry conditions could be bad because it was not enough water to transport things in the late summer on the rivers. But also very excessive precipitation could be bad because it created currents in the rivers, which ships couldn't, with their technology, go upstreams if it was too heavy precipitation events. So this again already shows that it's technology, that you have a lack of manure since you only have animal manure, that you are dependent on that it's not ice, that it's not too strong current, etc. Or how you mill the grain. They have water mills and you need enough water to the system to work. So this already in the first order impact kind of integrates the human aspects, the technology. And the second order impacts, what we have found or what have been found, is that we have significant climate effects on per capita availability and food prices, both on short time scales, but also on long time scales, even centennial time scales. And this can be empirically proven also, since we have very long records of grain prices in Europe, which I have worked with extensively and still working on. And we can also see that some diseases among domestic animals were favored by cold and wet conditions in winter, and there are also some evidence, I don't have it on the text on the slide here, that very warm summers, especially late summer seasons, could influence the spread of other type of diseases, both among humans and animals. But in generally, it's very weak links between climate and epidemics and pandemics. There are clear links, of course, between starvation and epidemics, especially how deadly these epidemics are. But other diseases, you can see a tendency, but it's no clear clear-cut causal links, and it's not a clear-cut relationship between climatic conditions and the spread of diseases that are valid for all periods and all places. It's diseases among the animals, not among the human beings. So this is really interesting. You can see here social vectors and climatic or environmental vectors interact in a way that we still not fully understand. We have seen it very clearly with COVID-19 that the spread in the northern hemisphere is so strongly correlated. The best variable to explain it is the air humidity that is determined by temperature, but it's also a lot of exceptions for that because of the social vectors that interacts. So even when we have the monitoring we have today, it's hard to understand fully these links, and of course with like fragmentary data in the past and not daily measurements either of weather variables, it's almost impossible. But this leads us over to the third order impact, the social effects of climate variability. And we can see that, of course, as I said, we have this first order impacts on the food production. And it had, of course, in a pre-modern society, direct effects on health, life expectancy, and also reproduction. You have an increase in mortality if you have a long period of undernourishment, because you are more you easier get infected, and these infections to a much higher extent can be deadly, especially among children and people in a weak health state. And you also have a decrease in birth rates for a variety of reasons and the periods of undernourishment. So this is quite clear-cut and well understood back into the times when this occurred. This was well known by Malthus, for example. That was one of the first to put it in a more scientific framework with a vocabulary that we are aware of today. But there was many other people far before that noticed this relationship and also in some cases try to quantify it in the pre-modern period. And we can also see that most famines, I worked with famines with a colleague in Oslo on Monday this week. Actually, we were sitting and working on famines and climate in the early modern period, and we can see that the combinations of various adverse climate conditions lasting for several consecutive years and internal socio-political factors, especially armed conflicts, decreased food security and could induce famines. And again, here we have this interaction between human agency and, so to say, climatic forcing on the biomass production. And it's not a fixed relationship. This is determined by time and place, both the environment of this place, but also the social dynamics and the social institutions on this place. Although you can see certain clear trends over time and of course over space too. And we can see that there also an effect on the nutrition, on human height, health and age of death through changes of food availability. This is a clear patterns that can be detected from present scholarship in the past 20 years or so, and even quantified to a certain extent. But we can't see really any clear link between climatic change and socio-political change. And when this is claimed, like a link between climatic change and the frequency of war or other conflicts, either today or in the past, it's typically no causal links proven. It's a lot of claims, but you can't really prove causality. And one famous example of that I took up in an article is that you, for example, said that the coldest states of the Little Ice Age in the late 16th and early 17th century increased the number of wars in Europe. But then you forgot the aftermath of the Protestant Reformation and the wars of religions. The scientists didn't even bring this up. And when you look at the cause of most of these wars, they are clearly driven by religious, so to say, considerations, and also the rise of absolutism in Europe. And the same today, when it's very clear that it's linked to ethnical and religious conflicts today too. And to get in climate in the narrative, it has to filters down a lot of layers, which makes it impossible to actually prove any causality here. So it's quite speculative. And this is the same with food availability and socio-political transformations. You can see in some cases that you change the political system after a food crisis that was mainly climate induced, but you have tons of similar crises where you have no socio-political change. And you can pinpoint and find, of course, always one example or 2 or 10, but then you ignore 100 other potential cases. So again, how you prove causality here, and what is a trigger and an underlying cause is almost important, but some changes might happen, and I can agree that it might be indirectly climatically forced in some cases, but it might happen 3 years later anyway. It's just the timing. And then we also have, so this is really difficult when you go from health and demography to society and institutions. Here you come on thin ice, so to say, when you are talking about the role of climate. And I would say there is the state of current research. And this leads us over to my Pro Futura project at the Swedish Collegium for Advanced Studies, and at the same time a Swedish Research Council project that have been going on since 2019 and to the end of to the next summer. And this is a project where I aimed to disentangle socio-political and climatic factors for famines in early modern Europe, mainly Northern Europe, about around the North Sea and the Baltic Sea, to look at them holistically and interdisciplinary, to understand the relative role played by climatic factors and socio-political factors respectively for the occurrence and the severity of food shortages and famines in early modern Europe, by together studying historical and palaeoclimatic sources to try to see under what climate conditions these famines occurred, and under what institutional settings you had a famine in the same environment, and when you didn't have it, despite you had the same climatic forcing and the same environmental setting and the same agriculture setting. Is it a coastal versus inland location, the transport infrastructure? Is it due to certain political regimes, to certain welfare system settings? Is it something that is consistently there when a famine occurs under a certain climatically forced reduction of food production? And is it some other things there in the society when these famines didn't occur despite the same climatically forced food production reduction? Is it a change over the course of the early modern period? We know that the severity and the frequency of famines decreases, but it occurs at different times, at different places, and what institutions or other factors are there or absent when a famine occur versus not occur. So this is partly a large-scale, large data project, and data collection efforts have been the identification, digitalization, and process of more than 300 food price records, yield ratio records, and also tax series from several hundred up to several hundred years in length. And the research team consists of myself as PI, 1 German postdoc, and 8 senior research project partners from 5 different countries and 5 different disciplines. And these research partners are working without a salary the other partners on their own funding. They are senior researchers in several cases that has some research time and happy to collaborate. But this of course also means that you can't keep a tight time schedule when you have, for example, two very good colleagues on the Danish Meteorological Institute. I also one colleague that is officially retired and can do it for fun whenever she wants, and but it's hard to keep a time schedule. But we have still published a number of articles so far, and one is about climate society interaction. What is the state of current research? And that was what I showed the first slides and talked about Ljungqvist et al. 2021 in Virus. And all these articles are of course open access, so they can be widely reached. And also Ljungqvist and Hoftoma and Ljungqvist is two other research articles, and the first one is actually published in a history journal in the French language to reach another audience. It was an invited contribution with professional translation into France. So we are also aiming to publish in a few other languages than English, and of course popular science stuff in Swedish, but also to reach a broader audience of both natural scientists and historians and also policymakers. And the biggest empirical article so far is an article came out a little over a year ago in the economic history journal Climatic, and it's about climate grain price relationships in the early modern period. And I may mention that there will be two more articles, one about famines and climate in the early modern period, late medieval early modern period, that will be submitted this spring, and also one article about the grain market changes and its implications for food security in Europe, a large-scale study of volatility and market integration and its implications for food security that is not about climate. And I also publish a number of popular science articles, mainly Understrecket in Svenska Dagbladet, but also other places about this topic. And to give a few examples, this is the first Climate and Society in European history that came out 2 years ago, that summarizes the state of the art. And the second article is in the Scandinavian Journal of History, Climate and in Nordic Historical Research, a research review and future perspectives. And this is about what the state of research stands in the Nordic countries. And this is important here to point out again that every second article comes out through a natural science outlet or general science outlet, and every second to economic history, and this is by purpose to reach the widest possible audience and also emphasize the interdisciplinary nature of the project. And then in the lower left corner you see this article about climate variability and grain prices, and this came to some surprising, I would say even for me, surprising results. We looked at all across Europe. We found a very strong impact up to multi-decadal timescales of higher grain prices in colder conditions, especially colder springs and summers. And this was quite surprising when we consider that southern Europe typically are more prone to drought in warmer conditions. But this is partly about early market integration. We could see also a clear connection that the prices of grain in northern Italy was to a large extent already in the 16th century influenced by the production in present-day Poland and northeastern Germany. Already then, it converted quite well across large sections of Europe. Surprisingly well. There are some regions that are not market integrated this time, and that's the Scandinavian countries to a certain extent, and Spain for political reasons. Portugal is influenced by prices far afield, convert to average European prices, but Spain first do it in the 19th century due to its protectionistic trade policies. This is interesting in itself, but we could actually explain by summer temperature alone as a single factor explains about 40% of the early modern grain price fluctuations on decadal timescales from 1500 to 1800. About 40% of the fluctuations can be explained by average European summer temperature alone. So it's and this is much more than previous studies have found, and it's actually much more than you're supposed, because you have treated the data took away due to inflation. It's a problem with the trend, and how you have decided in previous studies to take away all trends, because you thought that it's only on interannual timescales that climate matters, so like weather extremes from one year to the next. But what this article and my team could find, that the strongest signal is actually on multi-decadal timescales. Here is really what climatic forcing goes into, and it has new implications for the climax of Little Ice Age and how it's influence, of course, the economy at large. It was a grain-based society. About 70 to 80% of the European calorie intake came from grain alone. And then, of course, it's important to reach a wider audience. I only gave one example of an article in Svenska Dagbladet also, and podcasts. There will be a new podcast now in March and so, to reach a widest possible audience. And this project will have a few more articles that will be about the food market and its role for food security and its change over time. This is not about climate. That's on the working list for this year. Or actually, it will be intensive work next week with my German postdoc coming to wrap up a few of these studies. But we also have an outlook for the future, especially when you have been appointed a promoted professor. You're supposed to have some new projects, not stop research when you're 40. And I have no such plan. And kindly enough, the Marcus and Marianne Wallenberg Foundation granted me a larger research grant for 4 years for conducting this project. And this is a project that is a kind of continuation, but it's new research questions and a much more narrow geographical focus. And as you will see, the time also go into the early industrial time. And here is the research problem. How people and society historically adapted to climatic change? So we will investigate how people in the early modern era was affected by and adapted to climate variations in the northern Baltic Sea region. That is basically the present-day Estonia, Finland, and Sweden, eastern Sweden. And the main contributions here will be first to estimate how climate have actually affected, have varied over this time period, and how this have affected different sectors of society. And it will be, due to time limitations and data availability, only food production from grain and transport infrastructure on land and sea. And we will investigate how different historical actors have been affected. And with historical actors, I mean different groups like peasants, merchants, urban poor, etc. And how technology and also cultural aspects have interacted with changing climate, and how it have been utilized or not utilized new technology, for example, or new state of scientific knowledge in an adaptation process when it comes to agriculture, grain agriculture, and when it comes to transport on land and sea, prior to modern technology that comes towards the end of this period, increasing in the 19th century, when you can, for example, have land transport on the railroad, regardless if it's snow on the ground or no snow on the ground, bearing ice or not bearing ice, when you have starting to get ships in the 1860s that can go through the ice in the Baltic year round. And then we will develop new tools for studying climate adaptation in historical society that can be used for also other projects in the future, not only by me, but also by other scholars. And what is new in this project is that we use the terminology and the project use the terminology and, so to say, the tools, the conceptual tools and measures that are used in contemporary 21st anthropogenic climate change adaptation efforts. Typically, historical research has used another terminology for the same things, or for the human nature interactions in the past. And we are trying to use the contemporary framework, contemporary tools and contemporary terminology and measures, and apply this to past society to see. And this is, I would say, the main new contribution of this project. And of course, a bit challenging. And my last two slides can be, this too is second last, and you are the first one outside a very tiny circle and the reviewers of the Wallenberg panel that have seen this. And the text is maybe too small, but it's a time schedule that now already postponed 1 year for various reasons to get a project set up and start. So just 23 should be 24 and so forth. But it really shows the planned studies. And the first study is to systematically in time as well as space. That is also with the use of Geographical Information System, GIS, to look at on a Härad district level in Sweden on crop production from basically the time of Gustav Vasa, when we had the first records of production on a spatial scale, until the official statistics in the contemporary time. So basically we will probably go from about 1500 to 1540 when we have the first data, with some gaps depending on the region, until 2023 or something, 2024, which will be quite cool. Of course, you have a huge increase, and this increase is not due to climate, it's due to industrial fertilization and modern machinery and improved grain types, genetically improved seeds. So we have a per hectare yield that is maybe in the order of 10 times the 16th century today, and most of this increase has actually been post 1950, or a large proportion of it. But this is not this is interesting itself, but we also have the soil and how it have varied on interannual timescales across this period, and how the interannual variations have differed between regions, because we can have some regions that the stability is larger during that the stability have increased more in the yields than in other periods. So it's really a long perspective on grain production and how different climate parameters have affected interannual variation, both drought and temperature. And we have, fortunately, reconstructions that are reasonably good for growing season drought and growing season temperature, as well as winter temperature across this entire period, also prior to the 18th century, when we get daily instrumental measurements in eastern Sweden and also in Finland. And the second is to look at what can climate be one of the causes that you go from being a net exporter of grain, of rye and barley, to a net importer in the 17th century. I'm not claiming that climate is the major cause of this, but is it reasonable to presume that climate at least played a role in this very cold period for the need to go from being a net exporter to a net importer? Climate has not been even involved in this discussion before. It's old research, part that have many and speculations what this could be caused by, but this is, I think, an interesting topic. And then you have the grain prices and the mortality and the yields in Sweden and Finland from when you get officially statistics of births and deaths and causes of deaths. And this in the Swedish realm, that is Sweden and Finland, we have one of the longest such series in the world. They are longer in England, for example, in parts of England and parts of Switzerland, and even parts of Italy and Spain. But Sweden and Finland has among the longest statistics of demographic data. And it actually is rare that we have an overlap of this on parish level, where we have age of death, sometimes cause of death, gender, etc. And an overlap with a period where you still have demographic shocks due to basically food shortage. In England, and northern Italy, you have even longer data, but the famines and severe food shortages ended much earlier then, so you don't have an overlap with the crisis periods. In Ireland, in the mid-19th century, had a famous potato famine, but despite this being a part of the British realm, you don't have good really statistics yet. The conditions are so primitive, so most regions, they actually have famine still in the 18th, 19th century, don't have the statistics. And places where you have the statistics going into even the 17th centuries hardly have any famines anymore. They are so advanced societies already. But here you have an overlap with some of the last big subsistence crises, especially in the 1770s. And that goes to the last article to look at the 1771 to 1772, where you have an excess mortality in the order of 5-6% of the population. The cause of death is mainly dysentery, but it's clearly that is related to 2 years prior. The peak is in 1773, after 2 years of severe food shortage. And it's clearly that it's a relationship. In the same time, in present-day Czech Republic and Austria, you have an excess mortality of 10% of the population of the same, of other diseases. So these diseases are the cause of death, but the direct cause of death, but the underlying cause of death is malnutrition in 2 to 3 years. And here we have data on parish level, which is unique. So you can look at space and also look at gender, age, and in some parishes even the socioeconomic status of the deceased person versus the persons that survive. And then we have the last slide and the second second work package. And the first work package might seem very advanced. It's a lot of demographic statistics and also involve people from KI and people that work with GIS and so. So this will be an interesting, really interdisciplinary project, but I think it's entirely feasible. What I show you now on the last slide, I'm not sure if it's feasible or not. It's you have the first work package I know with the right people and the right computer equipment, software, and the right minds, especially, and the working time and energy and enthusiasm. We can do something fantastic. Here I don't know. Regardless of resources, I have the money from Wallenberg. I have my research time in my professorship. I know all the right people, etc. So, but still, I don't know. Can I do this? But I think it's good in this kind of bigger research projects sometimes take risks where you don't know what you will get or if you will get anything at all. But I don't think a big research project, especially from the funder's point of view, should be entirely a risk project. So therefore I put in one what I thought is a very interesting, will be good, solid empirical research, but a comparably low-hanging fruits, as we know that the data is there. And we know from preliminary studies that we can find interesting things. The second project, second work package, with transport infrastructure and how it has been affected by climate, that is a black box or a wild card, so to say. We don't even know if we can find. We know which winters was mild and more or less snow-free in the early modern time, but how did it affect the capacity, the transport infrastructure, and how this affected the capacity in forestry and mining in the pre-modern period? And we focus in Bergslagen and similar areas in central Sweden. Did it affect the productivity of the mining industry and the forestry in a notable way, so we can see it in economic records? We don't know, but we will investigate that. And floods and ice jams, that was a problem in certain societies along riverbanks. It was a big problem in early modern Finland with flooding, for example, of the city of Turku, Åbo. But this has only been studied so far for Åbo in the 18th century. Can we find any data for how you adapted to these ice jam floods earlier on and in other river basins? We don't know. no one has looked at it. And can we find any evidence for changes of prices on different goods and the feasibility of transport in the Baltic Sea depending on the length and severity of the ice season? I think we can, but no one has looked at it. And finally, the project will wrap up with a kind of policy-orientated article, maybe also based on the findings from my project that I will end this year with famines and climate in early modern Europe. But in general, a more policy-orientated article, we will discuss the concept of adaptation strategies and how you can use the climate adaptation discourse from contemporary research on a historical material and what implications our findings has for the role of social institutions in contemporary climate adaptation. Can you find some lessons from the past or not for the present? That will be the end goal of this project. And there I think I'm slightly over time, so I stop there, and I have no hurry today. I have another lecture first in the evening, so I'm very willing to stay on and try to answer to the best of my ability your questions. And thank you so much for listening on this.
Thank you very much. So entering the question and answer period, and as usual we take hands, which are full question, and fingers that are follow-up questions.
It might be on Zoom too.
Yeah, and we also have an audience online, and you should write, as usual, your questions in the chat function, and write your discipline too, so we know we like to mix people from different disciplines when we take questions. And for the follow-up, just write follow-up to the person you want to follow up to. And Moa, would you like to start? You're going to get a microphone.
Thank you. This is very interesting. So I'm a sociologist focused on experimental sociology. And as an experimentalist, I wanted to learn a little bit more about how you, because you mentioned causality on a number of occasions during this talk. And I know from experience that when you're studying the past, be it 10 years ago, or I guess in your case, hundreds of years ago, it is difficult to establish causality from correlations. Sometimes you can do it when you're studying extreme events, as a case of a natural experiment, but many times we don't have these extreme events. So I was curious to know more about what you mean with establishing causality compared to correlations, because sometimes when you did talk, it seemed to be more like correlations. You were talking about famine and factors that were there versus not there, and so forth.
This is a key topic, and I thank you for bringing this up. This is the most challenging in this research. I would say correlations, when you work at quantitative data, that's only the first step. The second step is to understand both what was said and understood in the time this happened, because that can be informative, how they link different things themselves, and we have some records of that. And the other is if it's a reasonable connection. As I said, as an example, that it gets colder and you got more wars. Yeah, you get a correlation. It's quite strong correlation, but you forget the most important factors like royal absolutism and war and the religious conflicts. So I think to have a holistic perspective and understand what type of, you have a lot of possible relationships, what relationship or understanding of this society makes sense, and what can reasonably be expected from our knowledge from like 1 to 2 to 3, or like 1A to 1B. What is not only we have some correlations, but what can be expected, and this can also then further be tested, fortunately, by one is correlations in itself when we have quantitative data. The second is what type of relationships make sense how this society how the society worked, what can be expected on a more theoretical ground and what is like generally reasonable. And the third is to look at what actually was understood in this time by people noting it down. How did contemporary people understand the relationship between factors? And they might make the wrong observations, they might be biased, etc. But we have we all have the benefit that to look at several societies afterwards, of course biased from our contemporary perspective, but I think we can at least connect by looking at large number of cases, relationships that are more or less certain. So in one way we can see causality in a general sense, but of course it depends on what you exactly mean with causality. And here is a key question, because in some of these fields, when it's review articles, very clear, especially for natural sciences, that you often only mean with causality only mean correlation, and you have a total different in many of the social sciences and humanities, a total different understanding of causality that is not always more clear cut. It's often hard to actually, when people claim causal relationship, what they base this on, also in like traditional qualitative history ideas or so. It's a bit of a challenge there too, and it's with all research it will also be probably for other persons challenging. So what I do is really to discuss and try to be explicit that is different understandings of causality. And when you have work with past societies, you can't do empirical experiments. You can make it in computer models, and that have been done, but it depends on the set of parameters. So you can't have as a high standing, so to say, high threshold, what is causality, as when you study contemporary conditions, for instance. You can observe them, and you can't set up the controlled experiments like you can in some sciences.
Are you happy with that, Moa? Yes, thank you. And then I will follow up on that, because it's a rather interesting question. And you took this case of religious conflicts, and it was correlated with some kind of climate perturbation. It seems, I'm not a historian, but it seems that you can do a lot of things to try to tease out what are the different factors. I guess you don't always get a religious conflict just because people of different religions are living adjacent. So you might speculate whether actually this is partly caused then by the climate change you have during that time. You can also look at the temporal order of it, and also, of course, the intensity of the conflict. So would you like to, since you were quite dismissive here, so I would like to hear
yes, because
about, those questions.
The first one is the temporal order. You have to modulate different lags, because when the conflict, so to say, starts with the first Reformation wars or the German Peasants' War, what else, it's actually a time of quite good conditions for production. So the temporal agreement, you have to start to modulate lags and different things. That's one thing. The other thing is that here I can't see, you can see food shortages, of course, among the general population and lower tax base as a reason for conflict. But when you actually look at the rulers and this type of conflicts, what they do is not necessarily any relationship with, well, let's say, the tax base or the nutrition status of the population, where the impacts of the wars, that's another thing, because in the impacts of, for example, the 30 Years' War was probably much more severe, higher civilian mortality rate due to the adverse climate conditions that occurred at the same times, because you had a very small surplus of food that's partly climate caused. And when the armies of several hundred thousands went around Central Europe and like requisite or say explicitly plundered it to feed the armies and also destroy the civil infrastructure, etc., you were much more vulnerable than if you would have a higher surplus. So the impacts of the war, it definitely interacts with also climate and also social vectors of spreading the plague and a lot of other things. But the outbreak of the wars, I would say here you have more plausible explanations, like the splitting into different religious sects on the same time, or the rise of absolutism, or new social institutions that can support, or new a new administration, for example, that can support a tax base that can support a larger wars. I would say here it's other more alternative explanations, at least from a point of view of a historian, that appears more plausible for the outbreak or the intensity than climate per se. You have a lot of factors, and some appears from our understanding of how society works as more plausible than others. So, but of course it's
all that seems very plausible. So maybe I should. It seems when you say the cause, climate change might not cause a war, but it might cause a war, but it might also be extending a war, or it might have worse consequences. There's a lot of different questions to be asked.
I think it's not the causing, but or the prolongation, but the impact on the population. Because, as I said, in a pre-modern society, to run the war, you need food, and you need it today. But since you have limited transport infrastructure in pre-modern time, you need it where the armies basically march, and also at home, of course. And you have other factors that you take drought animals to the war effort. You need a lot of animals died, and then you don't have less animals for agriculture production, also less manure that interacts. You need more manure if you have adverse climate conditions for agriculture, for example. So it all interacts. So I think the outcome interacts with climate, but I don't think the onset of the number or intensity.
So for that war, it seems to me that there's many questions to ask about the interactions. So I mean, one thing is when people say it causes, that might not be, but it might have a lot of impact on
a lot of impact. And here we come to different questions posed by historians. Geoffrey Parker asked these questions for the 17th century wars in a famous book come in 2013, a thick 1,000-page book, an American historian. More of the consequences, interaction of climate, when in the more purely quantitative environmental sciences, you often want two time series so you can correlate, and you only have time series of the number and to a certain extent the intensity of wars, but you don't have quantitative data really of the impacts in this period. So why you ask this question is a correlation between climate conditions and the number of wars. That's basically because that's the only data you can correlate, that you can get an annual time series of. And I think many of these questions coming from the purely natural sciences and some of the quantitative social sciences too, is that the demand to have two time series with the same resolution. And I can fully understand that, and you get a lot of interesting things about that, but that also limits the number of questions of the data you have available for this time period, because it's pretty few. You have grain prices, for example, which I could do a lot about, but we don't have even prices of milk, for example, that is well covered in time and space. And that's also why I'm not using the dairy production, for example, and climate, because I can't hardly investigate it in a good way due to data limitations, despite I know that there will be a huge impact on also, even if it was not a big calorie part, it was an important protein part of dairy production, but I can't really investigate it.
Karim, a microphone, please.
Yes, thank you. This was super interesting. My background is in philosophy, but I'm also very interested in these interdisciplinary aspects of the climate crisis, both in the past and in the present and the future. So I was a bit curious about your climate change and the different effects, first and second and order. And first, like one question, at least anecdotally, it seems to me that climate can not only influence in this kind of hierarchical flow, but it seems like climate change also influences directly the economy and health. For example, through frostbite, people die of cold in many countries, and so climate could directly influence health in that respect, and perhaps reduce productivity in other sectors than agriculture, maybe fishing, because the Baltic Sea freezes over. I don't know, but also in the third order, where climate change could lead to migration and those kind of things. One example of that is, I suppose, the Viking colony in Greenland, where that was abandoned. I don't know if that was directly a result of climate change, but
probably, but that's related to food. What food they could have.
I see. Yeah, my point is that one way that I've understood this story is that first that climate change puts stress on all these levels.
Or benefits.
Or benefits, yes. But also that there are interaction effects in the other direction, because now your arrows point downwards. But of course, social conflicts and involuntary migration can, of course, also increase the risk of epidemics and economic disruption and so on and so forth.
And it did influence the famine migration was how you spread epidemics and was one of the major causes of death. This migration, you were well aware of it in the contemporary time, that this migration during food shortages and hunger-related migration spread diseases, and you also very well tried to regulate it, because you knew even the well-to-do was the rich people started to die of these diseases during the famine crisis. You often got excess mortality in all social groups, even among clergy and nobility, due to this increased spread of diseases. So you were well aware of this, and I'm well aware of this also. The first impact order model of this type was published in 1981 in book chapter, and this is, I think, the 8th or 9th version, and that we updated, and we thought about this issue. There are some even more complicated ones that were published 2015, and they had errors in the other direction, but it was almost impossible to understand. The common way we had is to have this fourth order cultural focus on the bottom, and then you have an even longer. What we at least did was to place it on the sides, so you have an interaction. You see the errors in both directions here, so you have like religious, scientific, artistic reactions, crisis interpretation, culture, memory, learning, process, and adaptation. That goes at least the cultural or human agency go into all, interact with them all. Of course, you could have errors up also, but we only took like adaptation, social reactions, etc., that they interact with all. But of course, you're right that, for example, climate directly impacts also certain diseases, and also the work availability, frostbites and so, and cold-related deaths. They are typically the minor compared to, and also today compared, like heat stress compared to the production and. So we simplified it, but you have, of course, a direct link between. But here you have actually microorganisms in the first order, and they cause the diseases. So it's, I would say, this like diseases actually is in this order, since you need the climate affects the conditions for the epidemic vectors. But of course, you have like cold or hot conditions or flooding or so that directly can cause mortality. But you have on the built and natural environment, and I would say flooding, for example, indirect goes into there. So mostly it goes in this direction. But of course, you could have more errors back and forth, and especially with this migration and epidemics, you're absolutely right. You could have errors all around, so we simplified a bit. But what was new with this was to put the cultural focus on the sides, so it interacts with all and not on the bottom as you have done previously. So but it's a schematic model and not like a scientific interpreted tool.
Can I just short follow up? So I think I might not have gotten to the question, but I think that the question or the because I noted that in a later slide you noted that there's weak evidence of the direct relation between climate change or
in the literature, yes,
in the literature and conflicts, and I think that perhaps that I understand why it's difficult to prove causality, as Moa was also talking about it, and also because the direct link between climate and conflicts could be weak. But if we account for this kind of more kind of complex if we make a more interactive model, and I mean, wouldn't that strengthen the case of the connection or the causal, or maybe the increase in risk of violent conflict from climatic change? So that was kind of my...
Yes, I agree with you there. The problem is that then we get so much human agency, like we're talking about if you're how the society on an institutional, cultural, political level. So yes, we have more assumptions then about the relationship, and these assumptions might be true or might not be true. Please take what this article is not making any claims whether it can be an increase or decrease of different types of violent conflicts with climate change in one direction or another. It's just claiming that when it comes to, I would say it's still also true for contemporary research about contemporary conditions, that it's have been not proven in when we talk about causality, as Moa said, proven in or even made reasonable. Let's say that the evidence is contradictory and you have some articles claiming a relationship with the model and some others that build up. I have a similar article I use for my students on the master course that is related to the Syrian civil war and the Darfur conflict, that some claims and have claim to find evidence and other claim that it's no such evidence, depending on the number of assumptions. And why can you have so many assumptions? Come very good scholars, even in the same discipline, to different conclusions. And that's simply because there's several layers of this human agency in between, and depending on the assumptions you make, you can come to different outcomes. And this is not to say that it's not that climate wouldn't be a factor. It might very well be, but it's that it's hard to prove with reasonable certainty. That's the only thing why some things like the impact on human height or child mortality in the pre-modern period especially is very easy to link to climate-induced fluctuations in the grain harvest or the number of cows that survive or something like that. It's just that certain things actually can be proven beyond reasonable doubt, whereas you have some reasonable doubt, so to say, or different results in the scholarship, whereas some scholarship all show the same.
Olle, you had a follow-up?
Yeah. Thank you. I thought about the similar things as Karim, and I also thought about the applicability of this model to current situation, the type of climate changes that we're mainly interested in now are human induced, and that would then suggest arrows even to the upper.
Yeah, you mean you can have from like this, for example, especially this, I think, to climate, yes, because that's true. I think the only change you would need is to have an error from this to this, because otherwise I think this model works, but you would need to have like for the adaptation and cultural responses. You would need to have, since you will have different emission scenarios, you would have to have a link from the fourth order until the direct climate. That's absolutely true. Otherwise, I think, and it has been used in different varieties of this, also for contemporary, because you will still have with like in effect of the biomass production of different things, and like water in the to cool a nuclear power plant, how much water you have in the dam. That's, I mean, climate induced, or regardless if it's anthropogenically or not. And the microorganisms will still be affected, presumably in the same way. Of course, you will have other factors that you could have more of this cultural interaction, because you have more possibilities today to adapt, and you have like other means to like both control the microorganisms with different chemicals and so, and so I think this will be even more important, and you could have governance and so there too. But you're absolutely right that it should be in modern, it should be from here to here.
We follow up on that. Why not from the third order impact, demographic trends, and I don't know where you put consumption, but well-being is there, and consumption.
Yeah, you could have.
climate
I
change.
think you could have it there, but you can have, at least according to some researchers, a quite high consumptions, depending on how the production is produced. But of course,
but I mean,
demographic development will probably influence, at least if you have fossil technology.
Yeah.
You will of course affect climate change, but maybe it still filters through this. I don't know how you should put the errors. It start to get complicated. But of course, with the larger population increase, will most likely give rise to a higher emission scenario, and the number of. But we also have this decoupling.
It might be also the other way around, that you get a lowering, less climate change. If climate change will affect demographic trends, which will lower, and then that will.
Yes,
so
if you have if you are very deterministic or extreme, that it will affect the demographic trends. Yeah.
But where is consumption and production in this? Is that in the
Production of food is up here,
yeah?
and otherwise in this pre-modern society, I mean, you have economy could go in here, human well-being, that you consume shoes or hats, as I said, that the production went down. I would say I didn't put it in all here. I put in human well-being, basically. It could be economy also, but I didn't. The boxes were limited, so I couldn't put in everything. But you could put in. I put it, I think, in a human well-being.
This is for historical purposes. I thought Ole's
Yeah.
question, what kind of production?
I would have when it's. I would have. I think other things of consumption. I would have down here. I think, and also in the culture, maybe you would need a separate box. I don't know. There's different versions of this, but their main. But there have been a lot of this type of schematic figures, and some covers a whole page, and it's very hard to follow. And some are more simplified. I don't know what is best, because if it's too complicated, it don't work as a schematic figure. If it's too simplified, you always get. I don't know. I leave that to someone else, I think.
Yes,
Thank you. That was very interesting. So I'm a philosopher too. I'm afraid I'm going to continue this
That's good.
methodological discussion about causation. Right. So far we discussed, as I remember now, the question of what is the effect, right? Is it the impact of something? Is it the timing of something? Is it perhaps the temporal extent, how long something lasts? And also the sort of distance between the effect and the cause. Is it an immediate or direct cause, or further down the chain? But I think there's another issue which is also important, namely that usually when we talk about causation, we sort of pick out one thing as being the cause, but it's quite very context relevant, right? And I also think it's discipline specific actually. So, but to give you a boring philosophy example, so what caused the fire in the room? Well, Christer dropped his burning cigarette in the waste paper basket. Yeah, that's it. Well, what about the presence of oxygen? Right? Well, it's a causal factor too, but we put it in the background because normally there is oxygen in the room. Of course, you can imagine a case where it's not normal and someone is all of a sudden pouring in oxygen, and you might think it's different. But intuition about the causes will be different. So having this in mind, that we have to think about lots of causal factors, some of which we want for some reason to put in the background. As I say, it can be actually discipline-specific ideas that we're not sort of interested in that in the discipline. Then I wonder, isn't, for many of these pandemics, Black Death, isn't actually climate change now seen as one important causal factor? You said it was a very weak link, but as I understand, it's now a lot of research actually trying to show that it's not just a factor, but it's a sort of a driver. It's climate driven.
When it's plague, is there's some controversies there, but I also published on that myself. When it comes to plague, it seems to be a factor. Although, interestingly enough, you have found for the spread of the plague in Europe, the opposite, so to say, climate conditions from its emergence in Central Asia, where you're starting to get a pandemic that seems to start, or big epidemic spread in present-day Central Asia. And then what makes it favorable for spread in Europe seems to be other factors, but it's so therefore the research is somewhat contradictory. But the plague is one of the few diseases that you have seen actually a clear link. There are, reasonable assumptions that some other diseases will be influenced as well, but from historical perspective, at least, it's no research done. So because of lack of data and other things, there can be various reasons why no research have been done. But I would say in the historical literature, or not historical literature, even scientific literature, but about historical times, there are very little, for most diseases, very little research, especially research that point in one direction, and quite few studies overall. There have been some emerging in recent years, but most are related to plague.
Right. But so you agree that when it comes to the link then between climate change and some very important pandemics, one of the biggest ones we've had actually, Black Death, then there is not a weak
although
link, but
I would say it's probably a strong link, but the research literature, since this was a literature review, have pointed in different directions until the literature about 2020 is as far as we go. So this is not saying that it's actually a weak link, but that the research are coming to different conclusions.
But you said contradictory, but I think that's about where in the causal change you are, right? Because it's one thing to say it started in Asia, and there perhaps climate driven,
and
then the spread might not be climate driven once it's here in Europe, right?
But
that's not contradictory, right?
No, it's not contradictory. No. But some even have doubted the climate vectors in Central Asia.
Oh, that's different, of course.
And this is again partly, I would say, discipline driven, and that I would say the geography, physical geography, and environmental sciences, and those that work very interdisciplinary, I would say today agree that it's certain conditions, at least, that makes it to a pandemic in Central Asia, and most agree with more caution that it might be to a lesser extent the spread in Europe driven by climate conditions. That less certainly, but it points to that direction, and that the outbreaks are at least more likely to occur, much more likely during certain climate conditions in Central Asia. But people that work just with one type of sources, or just work, say, with the microorganism in microbiology or medicine, or like historians only looking at written sources or archaeologists only looking at like tombs or something sometimes still question this with their own limited disciplinary perspective. And in a literature review, I have to consider those that work in interdisciplinary, certain discipline, or those that don't even say that historians shouldn't look at anything except written sources. I still heard this. Some said that no knowledge outside written sources, not even archaeological material, if you have it physical there. I even have got say people, we shouldn't look at ancient DNA, even have people that die of this disease in mass graves that you can extract today. We shouldn't look at that. It's not proper history. There's still people actually claiming that. So I'm not agreeing, not at all.
Join me in thanking for this lovely talk. As you know, we have a little bit of a problem. We're going to renovate this space, but we have a seminar coming up February 22nd. It's going to be online with Rutgers University. And then March 8th, we have Paul Levine, who is working on, he's director of the Institute for Turkish Study. He's going to talk about Turkey and NATO, something like that. We will advertise where that's going to be, because it's not going to be in this room. But just check it up on the homepage. Thank you very much.